Have you ever wondered how your brain decodes the world around you? This is a question that neuroscientists tackle every day, diving deep into the fascinating realm of perception. Perception is the process by which our minds interpret sensory input, converting light, sound, touch, taste, and smell into the world we experience. It's the difference between seeing a burst of color and recognizing it as a sunset, or hearing a jumble of sounds and understanding it as music. Neuroscience, the study of the nervous system, plays a crucial role in unraveling this complex process. It allows us to peer into the human brain, discovering how billions of neurons interact to create our perception of reality. By studying perception, neuroscientists are not just exploring how we see, hear, touch, taste, and smell the world, but also how we understand, interpret, and engage with it. Our brain is an intricate decoder, translating sensory information into what we perceive as reality. Imagine your brain as an artist, painting a picture of the world. This is the essence of the representation theory. It suggests that our brain doesn't simply perceive the world as it is. Instead, it creates symbolic interpretations or representations of the world, acting as a representationalist. You can think of the brain's representations as a complex painting. Every stroke of color, every shadow, every highlight is a symbolic interpretation of the world around us. The brain doesn't just make a carbon copy of reality, it adds its own unique perspective, its own interpretation. Now, let's talk about neural reference. These are the brain's paintbrushes, the tools it uses to create its representations. Each neural referent corresponds to a specific aspect of the world, be it a color, a shape, a sound, or a feeling. Imagine a painter with countless brushes, each one specialized for a particular stroke or detail. That's how your brain works. It uses a multitude of neural reference to paint its own picture of the world. The field of neuroscience has made leaps and bounds in understanding the brain's artistic process. Cutting-edge methods such as in vivo real-time imaging and electrophysiology provide a glimpse into the brain's art studio, so to speak. These techniques allow scientists to see the brain in action, to observe how it uses neural reference to create its representations. This isn't just an abstract concept, it's a crucial aspect of how we perceive and interact with the world. Every decision we make, every emotion we feel, every memory we recall is influenced by the brain's representations. It's not just about what's really out there in the world. It's about how our brain interprets and represents that reality. And that's the beauty of the representation theory. It reminds us that our brain is not just an interpreter, but an artist, creating its own unique representation of the world. It's a fascinating perspective, isn't it? After all, who wouldn't want to think of their brain as a master artist, painting a vibrant, ever-changing picture of reality? Our brain is not just an interpreter, but an artist, creating its own unique representation of the world. Or what if we told you your brain is like a well-organized, dynamic system? Yes, that's right. One of the most pressing objectives of neuroscience is to map out precise structure-function relationships in the brain. Just imagine a cartographer charting unexplored territories. Only this time, the terrain is the human brain. With the advent of modern neuroimaging techniques, we've been able to make significant strides in this journey. These high-resolution techniques have given us the ability to observe regionally specific changes in brain activity, like watching the ebb and flow of the ocean tides. But it's not just about observation. Understanding the brain is like solving a complex puzzle. Correlational approaches serve as crucial pieces, providing insights into how different regions of the brain interact. General system theory then steps in, acting like the picture on the puzzle box, guiding us in assembling these pieces into a coherent whole. Just as an engineer understands a machine, neuroscientists are unraveling the complex machinery of our brain. So, what does all this mean for us, you may be asking? Well, let's bring it together. Perception is not just a passive reception of signals, rather it's an active process, our brain interpreting and making sense of the world. Remember, Our brains are not just copying reality, but rather creating symbolic descriptions to infer what's out there. This representation theory is crucial to understanding how our brain functions. It's our brain's way of painting a picture of the world. And it's this picture that guides our actions and interactions. Moreover, the quest to establish precise structure-function relationships in the brain is the ultimate goal. It's not just about locating where certain functions occur, but understanding the operational principles of this dynamic system. In the grand scheme of things, neuroscience doesn't just decode our perception. It deciphers the very essence of our existence. It's a journey of self-discovery, understanding ourselves and our interactions with the world around us.